morning, everybody. We're back for another lesson for today. Again, here are the reminders. Please pause and review them. Okay, we're going to start with just going over the answers from yesterday. All right, so I told you guys to drag and drop these words, right, into their correct place. So matter is made up of substances, or can be substances and mixtures. Substances can be elements or compounds. Elements are one type of atom. Compounds have more than one type of atom and they're chemically bonded. Mixtures can be heterogeneous or homogeneous. Heterogeneous are substances that have larger parts that are different from each other. Homogeneous substances that are the same throughout. If you do not have the correct answers in your notes, please do that right now. Next is also the answers from yesterday. So I gave you the solution of soda, and you were supposed to figure out the solvent and the solute. Now remember, the solute is whatever is dissolving. So, which is carbon dioxide, sugar, and artificial flavors, and then the solvent is water, right? I had given you the ingredients already. Now, what I did see going back, the common mistake is that carbon dioxide does dissolve in water as well, all right? Carbon dioxide is not one of the solvents, it's one of the solutes. This is just an example of gas dissolving in a liquid. Also, right, you had to write out what happens when a salt or any substance is dissolving into water, right? So when a substance is dissolving in water, whether it be salt or sugar, the hydrogen atoms are attracted to one of the atoms of the substances, right? And then the oxygen atoms are attracted to the other atoms of that same substance. And in that substance, we were talking about salt, which is Na and Cl. Water is a good solvent because it's able to separate the solute atoms apart to dissolve. And also because water is a polar substance, okay? If you do not have these answers, make sure to pause and copy them down. Something else that I want you guys to review for today is what solubility is. A measurement that describes how much solute dissolved in a given amount of solvent. Solubility does not tell you how fast a solute will dissolve. It tells you only how much a solute will dissolve, okay? Keyword is how much. And then concentration, the quality of solute present compared to the amount of solvent. All right, concentration, if something is more concentrated, then that means there's a lot of solute compared to the solvent. Okay, remember that solute is what's being dissolved and solvent is what's doing the dissolving. Make sure you pause the video to copy the notes. Now, what we're going to be doing next is we're going to talk about rate of dissolving. Rate of dissolving is how fast or how slow the solute dissolved in the solvent. All right. First thing we're going to test is surface area, which is the outside part or the uppermost layer of something. Right. So the surface area, the area of something. So right here, right, in both of my hands, I have salt. If you can see, these salt grains are big grains, right? And right here on the right, they have smaller grains. But they're both salt. Now I'm going to show you a video, right, that shows you what happens when I start to try to dissolve each one. So it's the same side. So right here is going to be the bigger grains, and right here is going to be the smaller grains. So let's watch. So as you can see right here, right, with the smaller grains, I stirred them the same way. This one dissolved way faster and there's barely any salt left. If I go back, right here, this is the one with the bigger grains, and you can even see on the bottom that there's a lot left, right? So let's go over what we just saw. Make sure to pause the video and copy these notes. Right, surface area. How does the surface area affect the rate of dissolving? The salt grains that were bigger have a bigger surface area. The salt grains that were smaller have a smaller surface area. This means that if a solute has a bigger surface area, then it will dissolve faster. Right? So smaller surface areas dissolve faster. Make sure to copy all of that down. Next, we're going to watch a video of stirring, okay? So in this video, the left side right here is stirred only a few times, and the right side over here is stirred more and for a longer period of time. I'm using the same salt and the same size for each one, and the same water and the same amount. Alright, so let's watch. I was just trying to take as much salt back into the water as I could. Now as you can see, I barely stirred that one, but look that all the salt is mostly dissolved compared to here where there's still a lot of salt left on the bottom. Okay, so what does that tell us? You guys probably already guessed it. Alright, how does stirring affect the rate of dissolving? When you stir a substance for a longer period, then the salt and the water molecules are moving and interacting with each other more, right? When you stir a substance for a shorter time period, then the salt and water molecules are moving and interacting with each other less. This means that if a solute is stirred more times and longer, then it will disappear faster. Not disappear, dissolve faster. Okay? Pause and make sure you copy that down. Next, here's the last one. So we're going to be talking about temperature, okay? So on the left side right here, I have hot water. You can tell it's hot water because of the water vapor that is on the cup. Right here, I have cold water on the right side, okay? And my beautiful hands right there. So let's play. Let's see what happens. I try to stir it as equally as possible, right? But it took me way longer to get the salt here dissolved, right? I stirred even longer on that side and it's still there, the salt's still there, but then over here on the left side where the water was hot, it was way faster to dissolve. What does that tell us, right? How does temperature affect it? When the temperature of a solvent is hotter than, the molecules are moving around faster. When the temperature of the solvent is cooler, then the molecules are moving around slower. This means that a solute will dissolve faster in a solvent that it has higher temperature. Same if we remember back when we were looking at the different phases of matter, right? We know that the molecules move faster in a gas, in a liquid, and when the temperature is much hotter. Now, you guys probably think, hey, miss, this is probably kind of useless. But if you think about it, you do this on your day-to-day lives, right? You can use a surface area, all right? If you want to dissolve something faster or slower. For example, if the only salt I had here, but I wanted to dissolve things faster, maybe I would crush this, all right, to get it to dissolve faster. Also, I would stir more, right, and keep stirring to get things to dissolve. And here, for example, if you want to make chocolate milk, I'll probably warm up the milk first before trying to mix and have the chocolate dissolve in the milk. Okay? Now let's look at a question, a very common question that you guys might see in the science state exam next year, 8th grade. So let's answer this together. The graph below shows how water temperature affects the solubility of 4 different substances. So here you have a graph, right? This is the y-axis and this is the x-axis. On the y-axis it says mass of solute that dissolves in 100 grams of water. That means the solute, right? And then the water is a solvent. So we have 4 different substances, right? NaNO3, KNO3, NaCl, and then SO2. Each line represents a different substance, and then right here you have the temperature. So the solid question is the solubility of which substance is least affected by the temperature of the water, right? So this is the mass, right, of solute that dissolves. So which one of these substances is least affected? How can we figure that out? I'm pausing so you guys can think about it. To figure it out, we have to look at this side, right? So we're going to see how the substances or the mass of the solute for each substances dissolves. So for right here, we know that the mass, right, keeps increasing as the temperature increases. So as the temperature increases, then for NaNO3, the solute dissolves more and more, or more and more the solute dissolves. Now for KNO3, same thing, is going up. So the solute keeps dissolving more and more as the temperature increases. And then NaCl, same thing, not as much, right, is dissolving as the temperature is increasing, but you can see a slight rise. However, the last one right here, what I see is that the mass of the solute that's being dissolved is actually decreasing, right? It's going down as the temperature increases. Right? We just talked about temperature as well. So that's why they're asking which one is least affected by the temperature. And the answer would be $4. Okay? Now the next thing I want you guys to do is complete the Google form in step 2 for today's date. Okay? Have a good day.